Hi, my name is Michael and I'm an engineer at National Instruments. Today I'm going to show you how to debug a device using the VirtualBench All-in-One instrument. In my setup here I have a VB8034, which combines a 350 MHz 4-channel oscilloscope, a 34-channel digital logic analyzer, a function generator with up to 20 MHz sine output, a 5.5-digit DMM with 300-volt input range, a 3-channel programmable power supply, and 8 general-purpose digital I/O lines. I'm plugged into my demo device, which is essentially an evaluation board. I'm outputting SPI data through this microcontroller through 4 digital analog converters, and I'm scoping those outputs. So let's go ahead and connect my device. Now in this demo, I'm going to be using the Windows application over USB, but there is an iPad application as well that has similar functionality. So as you can see, Windows detects the device automatically, so there's actually no software installation required to use VirtualBench. So I'll go ahead and choose to launch the software. So the software is already running, and I could start from scratch, but I'm actually going to load a configuration file that I saved earlier. It has all of my instrument settings just how I want them for this device. All right, now I'm going to go ahead and supply power to my device. Now in this demo board, when I supply a logic high on channel 0, I actually purposely introduce a glitch into my device. I'm going to click and drag to move this glitch into the center of the screen. I'm actually going to single trigger to make sure that I capture this. Now I'm going to use the mouse scroll wheel and zoom in. Now in characterizing this glitch, I want to see how wide this is. So I'll drag in a couple of my cursors and I'll measure this pulse. I'm tracking these measurements below the scope graph. It looks like my pulse is about 40 microseconds. So if I want to capture this glitch more reliably, I might actually set up a different kind of trigger. Originally I was just edge triggering, but I can set up a pulse width trigger to capture this glitch every time. So I'll go ahead and set these inputs as 0. And I'll configure this trigger for a negative pulse width between the range 0 and 50 microseconds. Now when I single trigger, you'll notice that I capture that glitch in the center of my screen. Now if I zoom in further, I'm actually decoding my SPI data on these digital lines. And if I take a look at what I'm decoding here, this 0 kind of stands out to me. So I might want to take a screenshot of that and take a look later. So that was a pretty standard VirtualBench workflow, but we can also add some more advanced functionality to this, like the measurements pane, which automatically calculates common signal measurements. You can click on a few of them to constantly monitor them beneath the scope graph. Measurement indicators that better visualize where a measurement is being taken. Digital phosphor acquisition mode, which displays multiple acquisitions simultaneously and provides a density map of voltage over time. XY mode to plot one channel against another and helps with IV curve characterization. And also arbitrary waveform from file, which you can play back a VirtualBench reference file or just a basic text file. So that's how you use the VirtualBench All-in-One instrument to debug a device. For more information on a VirtualBench, visit anna.com/virtualbench.